state is the intermediate state between solid state and gaseous state. Solid state is completely ordered state, whereas gaseous state is disordered state. So, in liquid, molecules are close to each other. So, the attractive forces are stronger than gases. Forces are stronger than gases. But these forces of attraction are not as strong. In case of liquids, the forces of attraction are not as strong as in solids. Okay, so solids have definite shape. Solids have definite shape. Okay, but in the case of liquid, the molecules cannot be separated from one another. There is forces of attraction between the molecules which are not as strong as solids, but the molecules cannot be separated from one another, and this results the definite volume for liquids. So, liquids have definite volume. Okay. Next, there are different properties for liquids. Okay. First property is vapor pressure. Here we are discussing about vapor pressure of liquids. Okay, so what is vapor pressure? First, if a liquid is placed in a closed container, what happens? If we take the liquid in a closed container, first evaporation starts and the molecules having sufficient energy overcome the intermolecular forces of attraction between the molecules and they will escape from the surface of the liquid. Okay, so first evaporation starts. And the molecules having sufficient energy escape from the surface of the liquid. Sufficient energy escape. Okay, escape from the liquid, from the surface of the liquid. As time passes, more and more molecules leave the liquid phase and they come in the space above the liquid. Okay, so more molecules are present above the liquid phase. Okay. Now these molecules above the liquid phase is called as vapors. Okay, these molecules are called as vapors. Vapors are present above the liquid phase, above the surface of the liquid. Okay, so next, molecules in their random motion collide with one another and with the walls of the container and with the surface. So, molecules collide with one another. Also with the walls of the container and with the surface of the liquid. Okay. So, the slow moving molecules, what happens? They collide with the surface of the liquid and get converted into liquid. Okay. So, slow moving molecules collide with the liquid surface and converted to liquid. This process is known as condensation. Okay, this is known as condensation. Okay, so there will be evaporation and condensation. Okay, at first only the molecules are in the gaseous state, but after some time due to condensation molecules gets converted into liquid. So a stage is reached at which rate of evaporation will be equal to rate of condensation. Okay, so there will be an equilibrium state between the rate of evaporation and rate of condensation, and the pressure exerted by the vapor at this stage is called as vapor pressure. Okay, pressure exerted by the vapors at this stage is called as vapor pressure of the liquid or saturated vapor pressure. Saturated vapor pressure. Okay. So vapor pressure of a liquid. Vapor pressure of a liquid at any temperature. Vapor pressure of a liquid at any temperature is the pressure exerted by the vapors, is the pressure exerted by the vapors, pressure exerted by the vapors in equilibrium with the liquid at that temperature. Okay, by the vapors in equilibrium with the liquid at that temperature. With the liquid at that temperature. This is called as vapor pressure of the liquid. Okay. This vapor pressure does not depends upon the amount of the liquid, but vapor pressure depends on nature of the liquid. Vapor pressure depends on nature of the liquid. Nature of the liquid. And also the temperature of the liquid. So, first nature of the liquid. The molecules which are having less intermolecular force of attraction can easily leave the liquid phase and reaches to the vapor phase. This means that their vapor pressure is high. Okay, so if intermolecular force of attraction between the molecule is less, intermolecular force of attraction between molecules is less, what happens? Vapor pressure is high. Vapor pressure is high. For example, acetone, then ether. These are having less intermolecular force of attraction compared to water. Okay, so these acetone and ether are having high vapor pressure than in the case of water at the same temperature. Okay. Next, temperature of the liquid. What happens? As temperature increases, kinetic energy of the molecules increases. Okay. So, molecules can easily escape into the atmosphere and vapor pressure increases. Okay. Now, what is meant by boiling? as we are heating the liquid, what happens? The temperature increases and the vapor pressure also increases. And after some time, the vapor pressure of the liquid becomes equal to the atmospheric pressure. Vapor pressure of the liquid becomes equal to the atmospheric pressure. So at that time what happens? The molecules present inside the liquid, inside the liquids gets converted into vapor and freely escape into the air as bubbles. Okay. So what happens? Molecules present as vapors in the liquid escapes into air as bubbles. This process is known as boiling. And what is boiling point? Temperature at which the vapor pressure of the liquid become equal to the atmospheric pressure. Temperature at which vapor pressure of liquid becomes equal to the atmospheric pressure. Okay. So next, normal boiling point and standard boiling point. Normal boiling point. So what is meant by normal boiling point? The boiling point at 1 atmosphere pressure is called as normal boiling point. At boiling point at 1 atmosphere pressure. Okay. Then what is standard boiling point? Standard boiling point. Boiling point at 1 bar pressure is called as standard boiling point. Boiling point at 1 bar pressure. There is a slight difference between this atmosphere and bar. So there is a difference between this normal boiling point and standard boiling point. For example, in the case of water, normal boiling point is 100 degrees Celsius and standard boiling point is 99.6 degree Celsius. Okay. Now let us have a notice at the graph vapor pressure versus temperature graph for different liquids. Okay, and we know that atmospheric pressure is 760 mmHg. So boiling point is the temperature at which the vapor pressure reaches atmospheric pressure. In the case of diethyl ether, normal boiling point is only 308 Kelvin. Okay, whereas in the case of water, it is 373 Kelvin. So in this graph, different plots are obtained in which vapor pressure is in mmHg and temperature is in Kelvin. Okay. Now let us take in the case of water. The normal boiling point is 373 Kelvin, ethyl alcohol 351.3 Kelvin and carbon tetrachloride 349.7 Kelvin, and in the case of diethyl 308 Kelvin. So diethyl ether is 308 Kelvin. Okay. So here in the case of diethyl ether, we can see the intermolecular force of attraction is very less. So their vapor pressure is high. So they will reach their boiling point easily. Okay. So the boiling point of diethyl ether is less. But in the case of water, the intermolecular force of attraction is high. Okay, so they will reach the atmospheric pressure, the vapor pressure reaches the atmospheric pressure, the temperature will be high. So the normal boiling point of water is high compared to all the other three liquids. Okay, so the boiling point depends upon the intermolecular force of attraction also. Okay, applications. Boiling point depends upon the external pressure or the atmospheric pressure outside. Okay, so boiling point depends upon the external pressure. Okay, so above the mountains, what happens? Above mountains, the pressure is very low. Pressure is low. So, liquid boils at low temperature. Okay. So, liquid boils at lower temperature. Next, in hospitals, sterilizing surgical instruments. So, sterilizing surgical instruments, what happens? In this case, it is sterilized in autoclaves. Sterilized in autoclaves, in which boiling point of water is increased by increasing the pressure above the atmospheric pressure. Okay, by using a weight covering vent. So, using this, we can increase the temperature. So, the boiling point increases by increasing the pressure during the sterilization of surgical instruments in autoclaves. Okay, in hospitals. This is another application